So this is the preview and reflect part. I chose to do lecture 2 rather, where it introduces a lot of the reactions. Oftentimes, I feel like this is nothing like an organic chemistry class, whereas now we have the unique advantages. We don't need to be very involved in all the reactions. We get to kind of take a more macroscopic approach to the different reaction types that we see on the MCAT, everything from SN1, SN2, E1, E2, whether we're doing electrophilic addition, nucleophilic addition, elimination ones, oxidation, reduction, and everything in the mix. What I've always aimed to try to do is make sure everyone understands the broad scope and say, sure, now that we understand the broad scope, there's 1,000 different reactions out there that you've learned through Organic 1 and 2. The idea, though, on the MCAT is not that we're going to ask you, what is this specific reaction, how does it work, show and draw the mechanism, and produce us a product. Instead, the MCAT's going to say, okay, we'll look at one of those, but can you tell us big picture what's going on? Is this oxidation? Is this reduction? Is this addition? Is this elimination? What would happen if I use this reagent instead of this reagent? The MCAT section is not devoted to understanding reagents and understanding how to go from product back to reagent or back to starting material through what reagent. But instead, if we can understand the general idea, like watching a carbonyl group go back to an alcohol, we can kind of talk in that perspective. So that's a little background information. So in terms of the preview part, so for this lecture, I always like to start by just kind of introducing the idea of when we go to travel. We see so many reactions in organic chemistry, and they all produce very similar products. It's just the in-between stuff that maybe we don't understand. So let's say I was going to drive here from UCF all the way to USC in California, for instance. I wouldn't necessarily talk about to just the general people if this was a general organic chemistry test, for instance, I would want to think just much more on the large scale of what's going on. Just like in driving, it's not like I'm saying I'm driving down the street to a neighbor's house where I need to use a specific road, on which road to specifically turn on and to get into which neighborhood, at which address, at which house. Those would be the very nitty-gritties that you already have done and seen in organic chemistry. You talked about very specifically named reactions, very specific reagents, and how they all work. So let's think about the MCAT in terms of us driving to California. It's not that I'd say I would make a right out of West Plaza Street, that I would take Alafaya down to the 408, which I would take west and run into this and that. In general, I would say, oh, to go from Florida to California, I know I need to at least start moving west. I have to get west. I know Florida is a long state. I know that here in Orlando, or somewhere here, I have to go all the way out to California up here. I know I have to move west, but I better move north first. There's probably some road or interstate that I could take to move me north before heading straight out west. And I know I need to get to California, and then we could say a little more specifically, I need to get to Los Angeles. So I know I need to be further south than north. And that's, again, the kind of detail that we want to use when we talk about the MCAT organic chemistry section. This is not organic 1 and 2. This is not one full year with the lab of understanding so many different techniques that you've learned in lab class, so many reactions that you go through at the end of every chapter that there's 3 pages worth. This, remember, is a grand idea that you're trying to use. You're trying to understand everything from a whole. So keep that in mind as we move forward. So at this point in the lecture is where we would actually go in and start talking about how do we take what are the reactions and synthesis of primary alcohols, secondary alcohols, tertiary alcohols, and how do we get those to go back and forth between their carbonyl compounds. So when we talk about primary alcohols, going to CO2, carboxylic acids, aldehydes, and ketones. And they say, okay, well, we know we can't make a ketone. There's 3 ways we can make that primary alcohol into the carboxylic acid, aldehyde, and CO2. So it would be a very macroscopic view of it, saying overall these are what we consider oxidation reactions. Going the other way, that's what we call reduction reactions. Here's an example, 1 or 2 examples of the reagents we use, but in general, remember, oxidation, it's going to involve gaining O's or losing H's. Therefore, the reagents should have a lot of O's in them. Reduction is the exact opposite. It involves adding a lot of H's and removing O's. So the reagent should have a lot of H's in them. So it's the idea of keeping a very, very, very broad scope here. And then to kind of wrap up the whole lecture, when we go back in and we kind of reflect on this, the idea is Now you understand what's actually going on here. When you see a picture, when you see a C double bonded O being turned into a secondary alcohol, your thought process should be, okay, don't get bogged down in the detail of what was the actual reagent that made it do that. I saw a C double bonded O turning into an alcohol. I know that's an example of oxidation, of reduction. If that's an example of reduction, in that case what I'm going to be looking for is some kind of reagent that has a lot of H's. Just like when we were driving from Orlando to Los Angeles, we weren't concerned on which road were we getting on to get out of here to start us going and tracking on the right road to get us north. It was, no, overall I know I have to head north to get out of Florida and then west to head towards the west coast and make sure I stay on the southern part of the west coast as opposed to just ending up somewhere randomly. So the whole idea behind the MCAT organic chemistry section, don't get bogged down in the details. Understand instead the bigger picture of it, which is I know going from an alcohol to a carbonyl is oxidation, and going from a carbonyl to an alcohol is reduction. And the materials I use to do this have a lot of H's if I want to put an OH on, or have a lot of O's if I want to take away the H's.